Okay, this is on your lab. So I talked about that we're going to do calculations, and this involves some trigonometry understanding before you can get to your wavelengths. So one of the first things is I have the green lines drawn like your meter sticks. And so you should have been measuring this way or this way depending on where your sink was set up at. Now, be sure to know if your meter stick goes from 0 to 50 or from 100 to 50, because that's going to make a difference. We need to know what this distance is. It should be the difference between the center to the outside. So if this is 100 and you're going to tell me that this is 70 centimeters away, it's not 70 centimeters away from the end over here. Okay? All right. So you need this measurement here. This is going to be called what we call an X. And then we need our measurement back to our diffracting gradient. That's our Y. And since we set these up to represent a right angle, that's the reason I put the clay in there to keep that from falling down, then we can apply Pythagorean theorem and do Z equals square root X squared plus Y squared. Now keep in mind we have one measurement for each one of the colors. And if we really want to do this to be a little bit more precise, we would have more than one measurement. Okay, once you get your Z, that represents our hypotenuse. Okay? So then I need to know what this angle is over here, because the angle will help me figure out what my wavelength is. So go back to trigonometry and remember SOHCAHTOA. Sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite over adjacent. In this case, I'm looking at, to get this angle, I'm looking at my X over my Z. So I'm going to use sine. So it's sine theta equals X over Z. Now remember, as you calculate this, you have X and you have Z. So you have to do the inverse of the sine to get the theta. Also, check your mode on your calculator. Make sure that it is in degree mode and not radian. If you have it in the wrong mode, it will not calculate right. So make sure we're in the degree mode. Okay? So it ends up being inverse sine X over Z, and then you should get a reasonable theta. Do think about your theta when you get it to make sure it does seem reasonable with your setup. Then, after you've acquired that, once I have my angle, I can figure out what my wavelength is. D represents your diffracting gradient. And on the diffracting gradient, at the bottom, it'll say how many lines there were. I gave y'all 1,000. Y'all's diffracting gradient had 1,000 lines on them. Okay? So, your D is 1 over 1,000. Sine theta. Theta is the angle you got from the previous one. This here is a conversion. Because we use centimeters, we need it to be in the measurements of nanometer, because wavelengths are measured in nanometer. Okay? Once you have that, it should give you your wavelength. So make sure it's a reasonable number. For sodium, the accepted value of those yellow lines, there's actually 2 yellow lines. For our apparatus, we're only going to see 1 yellow line. The accepted value is 589. So make sure that you find your percent error. You need to know how well you're doing. So always go back to the sodium. The sodium is always one that we start off with because it's an easy one to make sure that you adjust to, because you can clearly see it doesn't have a whole bunch of lines and that kind of stuff. Okay, thanks and have a great day.